Excuse me, Introduction to Networks. Week 7 already, Monday. Ethernet switching in the lab. We're going to talk about that in details here in a little bit. We talked about the network layer. Big thing there is IP addressing. Okay. Yep, IP addressing. And routing basics. We took a look at some routing tables and talked a little bit about those. Alright. This was the lab setup. So I'm going to talk through this a little bit. What the students did was, like group 1 with this switch, they went together with, looks like, group 5. So they took and unhooked this from the multi-layered switch, and then they hooked up a connection between the two switches. They had to put this switch on this network, and you can see that by a slash of 24. They are on the same network. Let's overemphasize that. Slash 24 would be those bits. And you look at those, same network. So they have the same default gateway to here, which would be, in this example, 192.168, 101.1. That's the address right down there. So it was the same setup for all of them. You know, it's just a matter of who was connecting with what. 2 connected to 8, 3 connected with 6, 4 connected with 7. Okay. And then we had connectivity between all of them. Should have been able to ping between all of them, and should have been able to telnet between all the different switches. And then they should have, let me see here, I'll use another color. They should have been able to put a PC, for example, 8 and 2, should be able to put a PC on each of those, communicate it between those PCs and those PCs, like this one. If I was to draw the path, if it was leaving, it would go to here and then to here. This then would route it. Okay, so if they were pinging another switch inside our network, well, then it would go out one of those 3 other ports. If they were going out to the internet, it would go that way. When they put on a PC, when they put a PC on those networks, like here, the switch learned that address, right? The MAC address of the PCs. For example, up here, this switch would learn the MAC addresses of all the devices connected to it. And this one. Now, if you had multiple PCs down here, all those addresses would be on this port up here, because that port would be pointing down to the other switch. Of course, then when they hit the switch, they go out the port that they match up with. Now, the communications, when they're pinging, right, these communications would have been, I'll use another color here, would have been full duplex, right? So the communications is going both ways at the same time. Same thing when they telnet. Now, if somebody would have connected to the Wi-Fi using their phone or their laptop, that's half duplex. It only sends one direction at a time. Rather than you can think of this as going both ways all the time. We talked about the ports, negotiating the speed depending on the two ends. They're going to negotiate the highest speed in the connections. We could see this is a particular network up here. We looked at that example. Here's another network here. And then down here, all of our switches are on their own networks. So, they finished up the lab. They have it submitted by tomorrow night. Both the labs from Chapter 7 should be submitted by tomorrow night. We did a little bit of a review. We talked about the data link has two sublayers. Logical link control talks about what type of information is coming down from here. An example would be, is it a IP version 4 or IP version 6 packets? The physical addressing, the media access control addresses are put on in the MAC layer here. Using 802.3, that's wired. 802.11 and 15, those would be wireless. And then the layer how they're transporting the data, we do more on that more later. Again, reminder, as the data comes down from the top, you know, whatever data is being transmitted, it gets encapsulated until the bits are actually put out on the median. And the reverse process occurs when it comes back. The bits come in, the MAC addresses are taken off, and then it's moved up, and then you look at the IP addresses, and if it stays here, it keeps moving up, or if it belongs on another network, it's going to re-encapsulate it with the framing that gets it to the next hop, and away it goes. Last thing I did was we looked in the multi-layered switch, and I did a ARP. Actually, more technically, I should write down a little different. I did a show ARP, and then it showed all these IPs and how they're matched up with a MAC address. For example, this would be a Cisco device, I can tell by the MAC address. Let's find a workstation. Here's a workstation. This is the address of the workstation. And you can tell by looking at this, right? This is the network that it's on. So what happens in a multi-layered switch, when the information leaves our network, let me use a different color. When the information leaves our network, when it comes back, before it's sent out this port to the other switches, right? There's a switch connected to there. It puts the right MAC address back onto the front, destination MAC, so then when it hits the switch, it goes to the correct device or PC. That is it for today.